Hi, I'm Monique Gurney, and Antonio couldn't make it tonight, and then the other three members of my group haven't responded to me, and it's 20 after, so I'm gonna just do the Google Hangout by myself, and if anybody joins, that's cool. If not, I guess it's just me, but I can't do it I can't do it tomorrow, and then Thursday's our next one, so. So I'm just going to go with the extension problems, and I kind of worked on these already before, and so I'll just kind of explain how I did. So I filled out the unit circle earlier, and then when you find the sin of a value, it's the y coordinate on the graph, and then when you find the cosine, it's the x value. So for the first one, excuse me, it's find the sin of 4 pi over 3, and then looking for the y coordinate, and if you look on the graph, or you could do it mathematically too, but I think since we had to use the, oh, it says use the unit circle, so that's good. So that would be negative square root of 3 over 2. The next one is sin of sine, I guess, sorry, sine of 7 pi, and that would be 0, because you're looking for the y coordinate. And then next one is 7 pi over 2, and that's negative 1. And then the cosine of negative 9 pi would be the x coordinate, so that's negative 1. And then the cosine of pi over 3 is positive 1/2. The cosine of 7 pi over 4 is positive square root over 2. And then the sine of negative 5 pi over 4, I think, yeah, so that would be, you have to, that one I had to add 2 pi to it. So when it's negative, when you add 2 pi to it and work it out, you find the coterminal angle, and so that makes the y coordinate the positive square root 2 over 2. Next one was the cosine of 19 pi over 6, and what did I do on that one? 19 pi over 6. I think I minus 2 pi. Let me just see if that works out. Okay, so yeah, so that one came out to the 240 degrees. No, I lied. 7 pi over 6, because I did 19 pi over 6 minus 12 pi over 6 equals 7 pi over 6, which makes the cosine the negative square root of 3 over 2. And then the second part of it was the fundamental theorem of trigonometry is an important identity. To have you better understand this theorem, answer the following questions as a team. So find sine of square root over 3, and that would be positive square root 3 over 2. And then the cosine of pi over 3 would be the 1/2. And then if you square both of those, you get 3/4 plus 1/2 squared is 1/4 equals 4 divided by 4 equals 1. And then from what I understand from the reading, I think this is always true because I think part of the I think it's the Pythagorean theorem. Slaughtered that, sorry. It says that the hypotenuse is always going to be 1. So I think this will always be true if you're using the unit circle. And then it says do the same process at pi over 4 and pi over 6. So pi over 4, the sign is pi over 4. Would be square root 2 of 2, and then the cosine is square root 2 over 2. Then you square root both of those. And then you get 1/2 plus 1/2 equals 1. And then pi over 6 would be square root 3 over 2. Oh, yeah, that's cosine, sorry. So 1/2. And then you're going to square root them and plus them. So 3/4 plus 1/4 4 over 4 equals 1. So it looks like it's the same thing. And I think it works that way because since it's a unit circle, they're all either coterminal angles, so they all have the coordinate angles, and I think that's why it will always equal, because you're squaring each one and it will always equal the 1. Okay, so next part says, in preparation for this Google Hangout, we a PowerPoint that explained how the sine and cosine values for each angle is found. So it's the Pythagorean theorem. Each time, because of the unit circle, the hypotenuse will always be 1. Using theorem x squared plus y squared equals 1. Since the cosine function is the x value and the sine function is the y value, you can substitute cosine squared x plus sine squared x equals 1, which is the fundamental theorem of trigonometry. It's easier to say. Okay, I think that's it. I hope that it's okay that I did it this way. I've never had this situation before, so if not, I apologize, but I did do the work beforehand to figure it out, and I'll let my group members know if they need help. I can help them, and that's it. Thank you. Bye.